Okay, case 3, the denominator contains repeated linear factors. Okay. Example, this one. Okay. X squared minus x plus 1. Actually, there's a close parenthesis in here. And then the factors of the denominator will be x plus 1, and another x plus 1 because it's to the power of 3. So that's repeated linear factors. So how do we deal with that? Okay. Again, we assume that there are constants a, b, and c such that a over x plus 1 plus b over x plus 1 quantity squared plus c over x plus 1 quantity cubed, okay, will give us this answer. Now, how do we find a, b, and c? We multiply all of these terms by this big denominator here. So we will have x squared minus x plus 1 equals, okay, x plus 1 squared. There's an a, sorry about that, there's a here. And then plus b, we have x plus 1 plus c. Now, we can assign clever values again. Okay, we can let x to be -1. So if x is -1, this is -1 squared, -1 of -1 plus 1, that gives us 3 equals, okay, this all becomes 0, and that is actually the value of c. Now, how do we find b and c? We cannot think of some other clever values. So, I think we need to expand this. Okay, there's another way actually of finding the values of a, b, and c. That is what we call equating coefficients of powers. So, let's go ahead and expand this. Copy the the left hand side, the trinomial x squared minus x plus 1 equals, if we are going to expand this will give us a x squared and then plus 2 ax plus a. And if we are going to expand this part here, that's going to be bx plus b, and then plus c. Okay, notice here, this will be, okay, the second degree. So we are also going to collect terms of the first degree. So in that case, we will have, okay, this one here goes with that. So we can write 2a plus b and then x. So when I mean equate coefficients of powers, okay, notice in here that on this side here, the left hand side, we have exponent 2. Right hand side exponent 2, that means the numerical coefficient here is just 1 and here a, so that means a equals 1. And looking at the first degree, that means the coefficient here is -1 and here we have 2a plus b. Okay, we have an equation and we already know that our a is 1. So that's 2 times 1 plus b. So we can also say that b is actually -3. So we get all the values, okay, a, b, and c. So we are now ready to go ahead and plug those values in here. Okay. The first part, we have no problem with this because the derivative of the denominator x plus 1 is just 1, so we can just write ln x plus 1. Okay? But this one here, we can actually write this as the integral of x plus 1 negative 2 dx. And we can also write this as the integral of x plus 1 to the power of negative 3 dx. Alright. Now, we have negative exponent, so add 1, that's negative 1, divided by negative 1, this becomes positive 3. And now, because the exponent becomes negative 1, we can actually write this as 1 over x plus 1 plus this one here, that's negative 3, add 1, it's going to be negative 2 divided by negative 2, this positive 3 becomes a negative 3 over 2. So this means you have to erase this. Negative 3 over 2. And then because this is negative 2, we can bring it down. So that's going to be 1 over x plus 1 squared. And then, of course, plus c, we'll just copy this first part here, ln x plus 1. Alright, that's the answer. Okay, the denominator contains a reducible quadratic expression. Okay, example this one. 3x squared plus x plus 1 divided by x minus 1, x squared plus 4. You know that x squared plus 4 cannot be factored anymore, so we will deal with this. So how do we set it up? Okay, this is how we do it. 3x squared plus x plus 1 over, okay, x minus 1 quantity x squared plus 4. So we have to break up the two factors. First a 2 plus b times 2x. Okay, where did I get it from? Okay, because I want that later on when I do the integration, I would like to see that the derivative of this denominator will be, okay, on the numerator, and of course plus another c over x squared plus 4. This is how we set it up if we have a denominator that contains a reducible quadratic expression. Okay, let's go ahead and work the problem out and multiply all the terms by this big denominator here, so it will only be 3x squared plus x plus 1 equals, okay, a, then x squared plus 4, okay, then plus b, and then 2x, then x minus 1, and of course plus c, and then x minus 1. We can also assign clever values in here. So one clever value that we can use is maybe a 1, okay, because I have here, okay, 1. If I let x equals 1, that means this is 1, 1, 1, this becomes a 5. Okay, this becomes 0, this becomes 0. So I have here 1 squared plus 4 is 5, so that is 5a. That means that a equals 1. Okay, what other values can I use? Maybe x equals 0. Okay, I can let x equals 0. That means if this is 0, this is 0, it's only be 1 equals, this term here is 0. Okay, this term here is 0, that means this is 4a, and this becomes minus c. And we know that a is just a 1, so that is 4 minus 4 times 1. Okay, Negative 3, that's C equals 3. How about the B? Okay, I think I can use negative 1. Alright, negative 1, that is 3, minus 1 is 2, plus 1 is still 3. This is negative 1 squared is 5a again. Okay, negative 1, that's negative 2, negative 2, that's positive 4b. And then plus, okay, negative 1 minus 2c. Did we do it right? Negative 1, let us see. So this means 3 equals, we know our A to be 1, so this is just a 5. And our C to be 3, that means 4B minus 6. What do we get? Okay, this one here is a negative 1, plus 1 is 4, that means B is also 1. Okay, so we got these values. 1, 1, 3. We can now plug these values in here. A, B, and C. So 1, 1, 3. ln x minus 1. This one here is actually plus ln x squared plus 4. And this one here is plus 4. We can actually write this as 1 over x squared plus 2 squared tx, so that, okay, one of our, okay, rules here is this one. Okay, using this rule here, number 3 on our list, okay, we can just copy this first part here, and then plus ln x squared plus 4 plus 3, and then we have, okay, using that rule there, we can have 1 over 2 arctan x over 2 then plus c. Okay, that's our answer.